This explainer shows how to roast sweet potatoes with perfect caramelized edges, completely solving the problem of pale, mushy results. Our strict goal here is getting those dark, caramelized edges. We're going to structure every exact step to completely avoid pale, steamed, or dried-out potatoes. You see, roasting requires a precise balance. We have to apply enough intense heat to the outside to trigger the Maillard reaction, browning those natural sugars, while managing internal moisture so the flesh stays creamy, not dry. Every single action we take directly manipulates moisture and heat transfer to hit this specific texture. A really common point of failure is using a low oven temperature. Low heat slowly bakes the interior without ever searing the outside. When your temperature hovers in the low 300s, the sweet potato slowly releases its internal water. That water evaporates and actually cools the surface of the potato, keeping it from exceeding 212 degrees Fahrenheit. Since caramelization needs temperatures well over 300 degrees, a low oven basically guarantees soft, pale potatoes with absolutely zero browning. To guarantee browning, preheat your oven to 425 degrees Fahrenheit. This specific high temperature is strictly required to trigger exterior caramelization. At 425 degrees, the ambient heat is intense, enough to rapidly evaporate surface moisture the exact moment it escapes the potato. Once that surface water is gone, the exterior temperature of the potato can finally spike past the boiling point, activating the browning of natural sugars and building a crisp shell. Now, do not cut the pieces too small. Small pieces will dry out and burn into shriveled scraps way before they reach proper caramelization. The size of the cut directly dictates the ratio of surface area to interior volume. If the volume is too small, that 425-degree heat penetrates to the center too fast, evaporating all the internal moisture. By the time the outside gets a dark sear, the inside will be completely hollowed out and tough.
Instead, peel and cut 2 large sweet potatoes into exact 1-inch cubes. Uniform 1-inch sizing guarantees even cooking across the entire batch. A 1-inch cube is basically the perfect mathematical balance for a 425-degree oven. It takes the exact right amount of time for heat to reach the center and break down starches into a soft puree, lining up perfectly with the time it takes the exterior to sear. Plus, uniform sizing ensures no piece burns while waiting for the larger ones to finish.
Next, toss the cubes with 2 tablespoons of neutral oil and salt until every single piece is visibly coated and gleaming. This oil layer is what transfers high heat evenly to the surface. Air is a pretty terrible conductor of heat, but oil is an excellent one. That thin film of oil catches the oven's ambient heat and conducts it directly into the potato's surface. A thorough, visible coat ensures uniform browning and stops the dry heat from just dehydrating the raw flesh. Whatever you do, do not crowd the baking sheet. Overlapping pieces trap moisture. As high heat hits the raw sweet potatoes, they rapidly vent steam. If pieces are touching or piled up on top of each other, that steam gets trapped in the tiny crevices between them. This trapped water vapor surrounds the potatoes in a localized cloud of moisture, immediately halting the temperature climb. The pieces basically end up boiling and steaming in their own expelled water, which completely prevents any browning. To fix this, spread the coated sweet potatoes in a strict single layer on your baking sheet, ensuring absolutely 0 pieces overlap. Giving each piece physical space lets the dry oven heat circulate fully around all exposed sides. This spacing acts just like an exhaust system. As the potatoes release steam, the open pathways allow the hot oven air to whisk the moisture away instantly. This keeps the immediate environment dry, which is the absolute prerequisite for the surface to actually fry in its oil coating. Do not open the oven door early during the initial roast. The internal heat will drop instantly, and the browning process will stop dead in its tracks. Every time that door opens, the oven loses a massive volume of stored thermal energy, and the temperature plummets. The heating element then has to kick back on to compensate, shifting the environment from a steady, intense sear to a fluctuating, lower temperature bake. Constant, uninterrupted heat is mandatory to build the foundational crust during the first half of cooking. So roast for exactly 20 minutes. Do not touch or move the pan during this entire window. Let the constant high heat do its work completely undisturbed. If you try to flip or shake the pan before the crust has fully formed, the potatoes will tear. The starches initially bond right to the metal baking sheet. It takes a full 20 minutes of high heat for those starches to dehydrate, crisp up, and naturally release their grip on the pan. At the 20-minute mark, check for the first visible transformation. You want to confirm that the bottom edges are starting to brown and visibly pull away from the pan. Look for a distinct dark rim exactly where the potato meets the metal. If the potato resists when you test it with a spatula, the crust hasn't finished forming. You must see visual shrinkage at the base. That indicates the starches have cooked and the piece is structurally sound enough to be turned over.
Once you confirm browning, flip the pieces over to expose the unbrowned sides to the hot metal. Return the pan to the oven and roast for an additional 10 to 15 minutes. This secondary roasting phase ensures an even, crispy crust on multiple sides. Since the internal structure is already softened, this final 10 to 15 minutes is dedicated entirely to managing the remaining surface moisture and deepening the color on the newly exposed sides, all without overcooking the center.
The roasting phase is complete when the edges become distinctly dark, crisp, and fully caramelized. The color should be a deep, rich brown, bordering on charred at the very sharpest corners. This specific visual cue tells you the natural sugars have undergone the maximum possible Maillard reaction without crossing over into burnt, acrid carbon. The surfaces should look completely dry and blistered, confirming that the high-heat oil transfer was a total success.
Finally, verify your result. The exterior must be visibly darker and slightly shrunken. Break one open. The center should be soft and steaming, not dry. You're checking for that required textural contrast, a robust, caramelized shell protecting a creamy, fully hydrated interior. If the center is firm, they needed more time. If the center is fibrous and dry, the heat was either too low or the pieces were cut too small. A soft, steaming center means exact execution.
Now that you've mastered precise high-heat caramelization to prevent steaming, what vegetable will you transform next?